Hey everyone, for this lesson I'll be going over some basic differentiation rules, which means you can take the derivative without using limits. All right, let's get started. So the first rule is the constant rule. The derivative or slope of a constant function is, well, think about what a constant function looks like. It's just a horizontal line. So the slope is always 0. So we would say the derivative of any constant is 0. Okay, so for this example, what would the derivative of 6 be? 0. All right, next we have the power rule. So if n is a rational number, then any function f of x equals x to the power of n is differentiable, and we can say that the derivative of x to the power of n is simply n multiplied by x to the power of n minus 1. So to see this in action with an example, you would take this x cubed function and just look at the power. So you're looking at the power 3. You take the 3 and you multiply it in front as the coefficient. So you now have 3 times x to the, what's 3 minus 1? 2. So our derivative would be 3x squared. So that's a lot easier than doing the limit as h approaches 0 of f of a plus h minus f of a all over h, but it works every time. Next, we have the constant multiple rule. So if you have a constant being multiplied by the function, this is also differentiable, and all we do is take that constant and multiply by the derivative of the function. So in example 3, if we're looking for the derivative of 4/5 x squared, you just keep that 4/5 in front like a constant multiple, and we're just going to differentiate x squared. So taking the derivative of x squared using the power rule, we get 4/5 multiplied by 2x to the first power. So our final answer when we simplify and just multiply those constants together would be 8/5 x. So that is the derivative of 4/5 x squared. If you want to prove it, you could go ahead and use the limit definition to validate that you do get 8/5x. Okay, now sometimes we have to rewrite the expression in order to use these rules to take the derivative. Take the square root of x, for example. In order to use the power rule, we have to rewrite this as a power x to the n. So we're going to rewrite it as x to the 1/2. Now we can go ahead and use the power rule for differentiation to find the derivative g prime of x. So the power is 1/2, multiply that in front, x to the 1/2 minus 1. So 1/2 minus 1 is going to give us negative 1/2. And what is x to the negative 1/2? Well, it's 1 over x to the positive half, which is 1 over the square root of x. And don't forget we have the 2, so it's 1 over 2 square root of x. Okay, next we have the function 1 over x cubed. Before we find the derivative, h prime of x, let's go ahead and rewrite h of x as x to the negative 3. Because remember, we want to be able to use power rule here, so we have to write it in the form of x to the n. So now we can take h prime of x. So using power rule, the derivative would be negative 3 multiplied by x to the negative 3 minus 1. Negative 3 minus 1 is negative 4. So we have negative 3 x to the negative 4. But we don't want to leave negative exponents in our answer, so we would go ahead and rewrite this negative exponent. So our derivative is negative 3 over x to the 4th power. All right, the last example is negative x to the 4th over 2 plus 3x cubed minus 2x. So here, there's really not much rewriting to do, but just understand how to handle this as a fractional coefficient. So if I were to rewrite f, I would just go ahead and take this negative 1/2 and write it as a constant multiple. And then we have negative 1/2 x to the 4th plus 3 times x cubed minus 2 times x. So we're really just taking the derivative by power rule of each of these terms and then multiplying by the constants in front. So to find f prime of x, the derivative of x to the fourth using power rule would be 4x cubed. Okay, the derivative of x cubed using power rule would be 3x squared. And the derivative of x to the first power using power rule would be x to the 0 power. Well, this is going to go ahead and equal 1. So just cleaning everything up and multiplying everything together, we have negative 2x cubed plus 9x squared minus 2 times 1 is just 2. So that concludes this lesson on basic differentiation rules. I hope that you enjoyed, and I will see you guys soon.